Hello everyone. I'm Remi. I'm part of the Tetration technical marketing team. I'm here with Tim. We'll come after and come and talk about other stuff to you. But first, we'll start with the segmentation part of Tetration. So, if you remember, like we already met previously, I think last year in Berlin, we already had some form of segmentation. So it's not exactly the same thing. So we did make some change. We're not just repeating exactly the same thing as what we did. So there's a few things I want to cover with you today, and there's the overall what Tetration can do kind of story. I'm sure you guys are very familiar now with the bottom part, which is how we collect, what we do, and so on. So I'm not going to touch that. I'm going to focus on the segmentation part here, and Tim will come and cover all the network and TCP performance parts in there. So very simply, that's what we'll talk about today. So a few things. Before we start, it kind of sounds logical, but everything I'm going to talk about is really designed to work on top of data, and data has to feed in from some form of sensor. And there were a few things that you've seen before. So I think we talked extensively about the software sensor and the capacity of enforcement at this point. We didn't talk, about the container sensor. So Tetration is capable of doing the enforcement in the exact same way as we do on a Linux host or a Windows host. We can do that in a container. We have the network sensor, which Tim will talk about much more around all what we can do in NPMD and all those kind of features. And we got your span sensor now. So I'm not sure, I think we didn't cover last time. Maybe Tim talked about it in a few months back. But instead of now having to actually install a sensor on top of our workload, you can actually span from a device that supports span, send it to a VM running wherever you want, and get all the telemetry there. So typical use case, the good old mainframes. These ones, you don't touch them, you don't go close to them. That's the perfect solution for you. Just go on wherever the top of rack switch is, span the traffic up, and so on. We also have NetFlow more as a kind of last resort option, to be honest. Like all other means have failed, we need to go somewhere. NetFlow is a good option for those ones. So that's the core information. That's really what we're really the most interested in there. That's going to give us, like we saw last time, the telemetry, the 5 tuples, all the TCP flags. It will help us understand the direction of the flow, who's the client, who's the server, all that kind of information there on the platform. Now there's a bit more information we can actually get, and that's where the actual context comes into play. We had discussed this around how we can actually add on some extra information on top of the platform. So now I have an IP address, and this IP address is tagged to a specific VRF. And now this VRF can have up to 32 whatever you want kind of tags on it. And keep that in mind, because that's going to be the basis of all I'm going to talk about, the tagging and this information that we're tagging. There's a bit more things, like if you remember last time we talked, you can ingest tags. You could bring like your CSV file, bring your tag, go and get your information in. Okay, so that's pretty nice. You can import from other platforms, third parties and others. Now you can also get them natively from the different platforms. So think about that. You have your environment, you're running VMware. You take your system administrator, he puts a tag on the VM through his orchestrator. Say, hey, role of this VM equals web. So then automatically Tetration will pull this tag and annotate any flows coming from this VM as role equal web in it. Which also means that from this point on, I can start looking more at how I'm going to use those tags to create groups. And I'm sure you're seeing where we're going on that. So how do you add dynamicity in your environment? We're talking about containers. Take them from Kubernetes, spin up 3, 4, 5, 6, 7 containers. Automatically they go in the same group. I don't have to do anything for that. So now we're rendering everything a bit more dynamic. Now why do we do that? And that's actually the new thing we've added in this version of Tetration is around understanding dependencies that you know, but previously dependencies were fairly static to some extent, like you put a host in a group and a second host in a group. What we've done is we've actually enhanced all the machine learning algorithms here to be able to say, hey, this machine goes in this group, but hey, based on the tags of these sets of machine, this is the tag which is the most appropriate for this group. So now we're building our application maps not based off servers that we put in the box, but based on the name of the box, and we let someone else fill it in. And that's what's happening behind the scene. Which means that first time, like let's say you're day one, you have your platform. Your platform is running half on Kubernetes, half on vCenter, okay, and maybe a bit of AWS spread here and there, because we all know like developers always put something over there. Now you end up in a situation where automatically I'm going to say, hey, sorry, actually, first thing, I'm going to run ADM to start with. That might help a bit. And the ADM is going to tell me, hey, based on all the patterns of traffic you're seeing, I'm seeing that the traffic is actually moving from this group of servers, host AB, to this group of servers here. Like, okay, nothing new. We have our two groupings which are done nicely in there. Now it's going to take the second step. This grouping has been done by the system. It's going to say, okay, now host A and host B in this specific scope have the same role tag. So now I'm going to assign the role web to those set of servers and to this group of servers. So now I'm going to lose the information of the servers as per se, because now server is anonymous for me. It's just the tag that counts. And I'm going to do the same for every single host across the platform.
So you have to do the tagging?
No, it's actually the tagging. Yes, absolutely. Well, we pull it from whatever you have. So say you have you use VMware, you put the tag in your orchestrator, we pull it out. You're using Infoblox or whatever. We use whatever we can find. Technically, if you really wanted to, you could just throw it a big mess of tags and let it figure out which tags work. That would work. I don't know, for the user friendliness might be a very different debate, but the solution would work.
Technically, it would work.
Technically, it would work, exactly. It would also group multiple tags, so it would also be smart, like not looking for one tag, because obviously, like if you have multiple tags together, it's like, yeah, I'm trying to find out one, you might not be very accurate. So it's going to tell you, well, app and role need to be at the same for it to work correctly, or a third, a fourth, a fifth, etc. And what it will do, it will suggest you what are the tags. So you decide, because maybe there's 5 or 6 options for the tags, and maybe you want to put some sort of input there. There might be some legacy tags. I mean, I know it never happens in data center, but yeah, you might have some legacy stuff around with wrong tags. So you can say, no, I want to use this tag, not this one in there. Is it kind of clear how we kind of group at this point? Okay. So I'll show you what it actually looks like in the UI rather than spend time on the slides. So I have to do a recording as well, right? So hopefully that's one, I guess. Yeah. Okay. Okay, so that's just a regular Tetration cluster, 2.2 release there. If you managed to read it, congratulations. I have pre-built a few workspaces just in the interest of time in there. So this is our infamous cluster, Berkshire. Thank you, Tim, for this naming. Which has been created based on again, same logic, same principle as we saw last time. I'm taking flows in, I'm grouping them, understanding. But there, if you remember previously, the screen was actually split in two, and you had the clusters here and a set of servers inside the clusters. So now, if I go to a server group, I'm going to do a query instead of a server group. And that's where it becomes pretty interesting. And you have also, obviously, the alternates query. So say I'm not happy with this one. Okay, well, where's my mouse? I can go and it tells me, look, based on what you gave me, I think that all of those would be good candidates for that. Maybe I'm not happy with role. Maybe I want to use app contains varnish instead of that. That might be a good one. I mean, you can go and you can just go and change it.
And app you get from process list on the host.
No, app is actually something that's important. So think about it like in a production scenario, that would be a CMDB. So take, say you're using ServiceNow. ServiceNow is going to group things in applications, because an application can be like 5-6 tiers inside one big app. So we would, for example, pull that out of ServiceNow as an example, but anywhere you want to put it is good for us. It's obviously like API driven as well. So if you want to bring your own stuff in the way you want, like for example, where we are using our custom.
Not reverse engineering this based on the processes running on the box.
That's correct. That's correct. The reason is let's say the quality may be a bit dodgy, and the problem is that if I compile a software and just rename it and I call it Nginx, and then you change all my grouping, and like that might work well, but might end up really badly as well. So that's why we don't use this approach. We tried, but that's it.
So you had this discussion before.
We had this discussion before. It didn't work out exactly as we wanted, so we said, okay, let's forget about that. So now, what I've done now, exactly how I had before, my groups of server are now my tags, and I'm setting policies between my different tags. So I've moved to an environment where basically I'm going like one step, like I've been a bit provocative on purpose, where IP address doesn't matter. Wherever the IP address is, I don't care an inch in this model, because for me a VM is a tag. This tag will then derive an IP address when I'm actually rendering the concrete policy. But before then, I don't care.
So you are putting the goals to put this into more human readable buckets, yeah, where you can see, okay, this talking from DB to web and vice versa and so on. Okay.
So completely simplifying, and those, of course, you name them as you want, obviously. Like, I mean, those are things that we put for consistency's sake, based on the tags. If you wanted to rename that, say you want to use tag middleware and name, I don't know, SpongeBob or whatever, you could do that. I mean, nothing would stop you doing that.
Back in the days, I don't know, Donna just talking to Daisy again and so on, yeah?
Yeah, if you really want to go there, you can go back to the good old days.
And then as you spin up new VMs for scaling, would they automatically get the correct tags and automatically be in the right groups, and so the policies would be updated with new IP addresses, yada, yada, yada?
Exactly. VM or containers, or it could be something running in AWS or like wherever you want. We really don't care.
As long as it has an IP address and you are able to find the tag for it. Yeah.
Yeah. Or the tag is populated by whatever platform. So you could say, like, if you, depending how you're using it, AWS is a good example of that, obviously. Like, you're using AWS, you just right-click, spin up a new instance. It already has a set of tags defined. It comes up, sensor connects, registers to the cluster. Okay, I know this VM is up. This VM is coming from IPX. In there, IPX is now assigned to tag Y. And there, oh, okay, this is this group there. So all the policies move automatically on this VM. I don't need to do anything. So scaling, simple, but the thing is that, like, you probably saying, yeah, well, if I have Kubernetes, I can do it through Kubernetes. But yes, maybe, but you can do it across platforms. And there, you basically have a single policy plane across all your environment. And no, it doesn't go through IEEE and stuff like that for the fun of it. Now, so that's kind of your policy. Just to have a quick look on a server. And this screen is small now. I'm just going to connect to one of our hosts, if we're lucky. We are lucky. We've rendered a whole set of policy for you inside this environment. Now, a few things that are important. First one, when we render the policies, you notice that we actually match IP sets for scalability. Because obviously it didn't work out very well otherwise. And the second reason for that is, if I can find where my mouse has gone, it's also for dynamicity. Because I can now very easily modify an IP set to add hosts into it, create groups, add hosts, modify hosts. I'm actually not technically touching IP tables when I'm doing that. I'm modifying just the IP sets for that to work correctly. So now to have an idea, now that we talked about it, like I'll pass all the usual kind of, we can track and monitor this policy, you have all the details around that, like you know all the marketing around that, so I won't spend too much time on that, but this is absolutely, I want to spend a bit more time to understand how we actually render the policies, because I think that's a part which is much more interesting in terms of approach. And then there's a few things around it. So if I take a very basic example, server 1 talking to server 2 over port 80. I mean, that's all. My provider or my server is going to be server 2. There's two things we do in this case. And for the sake of this example, consider I'm running within the same workspace. So I'm running within the same environment. So if you think, if you remember the workspace concept, you can have one application or one workspace, and you can have one owner of one workspace, and you can have multiple workspaces, multiple owners, how you can basically apply RBAC across the platform. So in the same workspace, I'm trying to open communication. So I'm going to do two things when I'm going to set up a rule. The first thing, I'm going to configure my server side. That seems pretty logical. I'm going to configure input and output on every single of the IP tables here. Because the default as it's configured here is deny. So if you look at my output rules, if I come back here, the default is drop in there. So that's basically my default rule, what I configured here. So I'm bringing that back. And here, I then basically punch holes only for communications that should be going through in and out. And I think that's a very important concept, because in most cases, the tendency is, in is a bit tricky, so we'll make sure in is correct, but out, well, it's okay. I mean, my workload is secure, right? It always is. So now, sorry?
I never mess it up.
You never mess it up. It will never DDoS anyone else, right? Because it's okay. So those are all the reasons why we tend to not configure out for a wrong reason. So now we configure this every time. So basically, we're making statefulness now between the two. So I now have a source packet coming in, a destination packet coming in. The source out is actually verified as well. So I guarantee statefulness there. But we don't stop there. We actually create a second rule on the other side for the exact same one, but just reversed. So we're making sure when we create a rule, and that's when we talk about whitelist policy model, where we actually go pretty far in the whitelist policy model, we actually make sure that the server is protected, but that the client is protected as well. So we're just allowing one client or more, because this rule is derived automatically for you on every single server, is only allowed to talk to one server.
I totally agree with all this, but don't you get this automatically with IP tables and with stateful connection tracking?
On this side, yes, between those two.
Yeah. On the other side, no?
No, because this is another server.
Okay.
So as you're on a completely different host, maybe this server could have, permit IP any.
So when you establish an outgoing connection, you don't get a reverse entry automatically in IP table.
No, you have to put, so either you enable a default rule at the end, which is like allow all established and so on. You can put that. It's not by default, but you can put it. We actually restrain it down to the port level, which is not something which is necessarily done nowadays. And by the way, I took the Linux example. Obviously, it works in the same way on Windows, because people are more familiar with Linux IP tables. Now, let me show you kind of a little different approach. Tetration has the concept of friend requests, in the sense we are trying to make sure that you have owner A and owner B. They own two completely different applications. They never talk to each other. Obviously, it's purely theoretical. It never happens in the real world. but they own completely different applications. But we want owner A to be able to ask for a port opening to owner B without talking to the other one. That's the idea of the friend request. Obviously, we're trying to avoid the Excel spreadsheet as well by email. I mean, that's obvious, but we're very happy to stay away from that. So the way we do that is we actually took a two-step process in there. First step is I'm controlling the A side. So I'm going to create my policy. The policy is going to be derived on my side because I'm the client, I'm trying to access a service being provided by B. But I'm not going to create anything on the other side. So meaning I can try getting to this server, but this server will never reply to me. So basically I'm isolated at this point. Now in the Tetration dashboard, you will have the friend request that will come in. So you see that little red thing there, sounds really small. There's a number of requests. Just like when you're in Facebook, you see your request number at the top there. And I'm going to have a look at that, and I'll have the list of all my policies. I say, do I want or not to accept this connection?
Oh, so it is like Facebook.
It is exactly like Facebook on that side. It's very simple. You can accept or reject, as usual. There's no kind of ignore on that because we're not completely in the Facebook mode. But you have the two options. And at the moment I'm going to click on accept on the receiving side, then I'm going to set the policy. Which means I still keep full control. You don't need to do the kind of the arbitrator between the different teams and sit in the middle while they fight. Just let them send the policy. Do I want to accept it? Yes, no. Is it within policy? Yes, no. I'll go for it.
Can you use tagging or grouping from the other workspace when sending the request? Or do I have to know the IP address of server 2, or can I just say, well, I want to connect to the database servers in workspace 2?
Absolutely. You can use the grouping and the tagging. Actually, the user defines what he wants to show to you. So he can say, hey, I want to show you my database, or maybe it's like, imagine corporate internet server. I want to expose my API endpoints to the internal application developers, but I mean the public portal I want to offer to every single user in my environment. So you define that.
So you can even include the port number in the service definition that you expose.
You can't expose the port number, you expose the group. Today, port numbers is definitely something that we are looking in. So we don't expose port numbers. When we do the request, obviously the port will show up in there. Now there's also what we call autopilot rules, meaning like imagine DNS, if you had to click accept for every single DNS server, I mean that might take quite a bit of time in there. So you can define rules as well of when you would accept something. So say corporate intranet server, if the connection is coming from the set of the development servers which are owned by the API team, I'm going to automatically allow connection over 443.
Can you just give me an example? So I have a label, for example, for my left side server 1, and actually this label regarding to 3 machines in 3 different subnets.
Yeah.
And you push down this policy. Will all 3 receive the policy for all 3 subnets? Or will it be for each server an individual policy that is only getting his own, let's say, policy enforced?
So you said the label will be the same.
Yes.
So you will get one policy request because you're going label to label. So you get one policy request in there. Now when you accept this policy request, Tetration will derive automatically all the subnets where it needs to be applied.
So on all servers, I will see a policy that has all the subnets in that label, yeah?
Only if they're pertaining to your connection, of course. I mean, like we don't derive, for example, say you have a workspace with 10,000 rules inside it, and the server 1 only is basically just concerned by HTTP traffic. We will only apply the policies linked to HTTP on that server. Okay. So we do derive, like it's a very specific set of policy for every single server. And the reason for this approach is actually pretty simple in there. take this example. Let's imagine we have 4 servers, and 4 servers are running host-based firewall, and they're all configured correctly. You're happy with the communication. Now, if I go one step further, and let's say I manage to compromise this server, compromise, misconfigure, like you decide the wording you want to put around it. But imagine I'm trying to connect out. Well, the IP table's output policy is going to protect this for me. I can't do anything because anyway I'm going to be stopped at the edge on that.
Yeah, but that assumes you didn't get root access on that misconfigured server.
Perfect transition, thank you very much. So imagine you get root access on that server and you do manage to kill the firewall on that. Or let's say you kill the Tetration agent. If that was to happen, well, all your servers, just like on the same principle as an immunization, are actually protected because each of them has an individual policy. So you never have an open free-for-all between 2 servers across there. So it's still very secure in that environment. Of course, you probably want to act, so you will get a warning and an alarm around those things. But yeah. So does that make sense? I see Brianna, it's actually my last slide. Does that make sense? Good. Any last questions?
I have one. So it seems like it's only me who finds these weird similarities between products, but this sounds, I was about to say before you ended up the last part about cross-workspace interactions, it looks very similar to Lumio.
To Lumio?
Yeah. The last part it doesn't, and I think that's the biggest selling point that you have against Lumio.
Exactly. And there's much more like it. You have an absolutely perfect point, and that's a conversation we often have with the customers. Is like they come with a part of the solution, which is okay, and they focus on that area. We think we can do much more because again, the data is key in what we're getting there. And as we're ingesting and storing all this packet data, like remember, it's exactly the same set of data since the first time we presented Tetration to you. And since we brought you ADM, then we brought you ADM with dynamic groups, ADM with dynamic groups and enforcement, enforcement with dynamic groups, and so on. So we are leveraging this data and increasing the capabilities.
I think also the key would be for you to stay as much vendor agnostic as you're allowed to.
Exactly. And actually the good news is that we're actually allowed to stay very vendor agnostic in there. Except Tim will show you things that are related to the ASIC, so that unfortunately, I mean, we have to stay vendor agnostic, but you notice the agents are actually, I mean, completely open. We don't force you to use Cisco OS version X on that. Red Hat, wherever you want to run it. UCS, non-UCS, I don't care. No, it's a C binary that's there. It's compiled, but we have a very wide range of OS supported. So for example, the first OS support is like RHEL 5, which is already ancient to some extent. We do have some for AX as well, and actually most of the platforms that exist out there.
Just one question here. You talked about the policy enforcement on the client, with your client running on the end system. Are there any models enforcing this policy to devices that are on the networking path?
There's work that's been done at the moment. So there's, first of all, it's kind of 2 answers for that. If you're Cisco only, obviously we're looking into approaches on how to embed that with ACI much further. And if you're not, we're actually exploring the policy in a standard format, which means that if you're using Tufin, Illumio, AlgoSec, I don't know, my brain is like forked on that, we actually can take this policy and push it out to those platforms as well.
So if I get you right, ACI is on the horizon, yeah? Will come, okay.
Absolutely. If you go to the product session actually tomorrow, I know you're big fans of the session, but if you go to the product session tomorrow, they're actually talking about that.